All right, hello viewers. My name is Mr. Ayodeji Ogunyeye, also known as David Max. I'm here again with another topic, projectiles, for the maths topic for secondary schools. So let's take a quick look into this topic very quickly. Now, our objective here in this lesson is to know how to use components of velocity to solve problems about motion under gravity. So we want to believe that you already have a prior knowledge of Newton's first law of motion, forces at an angle, and also kinematics. So let's get right into it. A projectile is any object which is projected from a point. And for example, you could have a cricket ball, as you can see. This ball, this is the cricket ball, is being projected from the bat that the player is using right there. So you can see the trajectory, the direction in which the ball moved. Another example is a cannonball, which is projected from the machine here. This is the cannonball. Another example is a bullet projected from the gun itself. You can see the bullet and the trajectory direction in which the bullet is going. Now, they all have one common feature. The only force acting during flight is the force due to gravity, which is the weight of the object that is being projected. Now, if we have that, note that you might be thinking that another force that might be affecting the object, okay, or the objects that we have in this example could also be the air resistance, okay? But we need to note that we always ignore air resistance as we have done before in other topics. This means that the only acceleration which acts on a projectile is vertical. That means downwards. So if you project any object, whether vertically upwards or horizontally, you would expect that there is a vertical force that is always trying to push that object downwards. Remember that we talked about that kind of force which we call gravitational force, always trying to pull every object back to the surface of the earth, which is the major reason why every one of us, even as human beings, all objects are actually glued to the surface of the earth. We are not floating. It's due to the gravitational force. So there is an acceleration due to that gravity that is always acting on a projectile, okay? And that is given as the small letter g, which is 9.81 meters per second squared to 2 decimal places. All right, approximately in some textbooks, they might give it as 10 meters per second squared to the nearest whole number. Now, take note of this. In projectiles, there is no horizontal acceleration. Okay, there is no horizontal acceleration. Remember, the only acceleration that is acting, okay, the only acceleration that is acting on a projectile is simply acceleration due to gravity. That's your G. There is no other acceleration. Okay, that is why we say that there is no horizontal acceleration. So don't think there is another acceleration that is acting somewhere. All right. Now, this means there is no change in the horizontal component of your velocity. Because if there is no horizontal acceleration, then there is no change in the horizontal component of velocity. What does that mean? Remember, that's why we said that you must have had a foreknowledge of your Newton's first law of motion. Remember, you were told that V is equal to U plus AT, where your A is the acceleration, your T is time, and your U is the initial velocity. So definitely, if you have the horizontal acceleration right here, this horizontal acceleration right here, and you know that based on what we are talking about, that acceleration is 0. That simply means that 0 times t will become 0, okay? So we can simply have it that v is actually equal to u, which is the initial velocity, plus 0 multiplied by t. And definitely, you know, that means that you're going to be having 0 times t to be 0, and then you still have basically that your v is equals to u. So this means that your initial velocity and your final velocity are going to be the same all the time in a horizontal component of the velocity. So that is why they said that this means that there is no change in the horizontal component of velocity, okay? Because the initial and every other velocity in the horizontal component at any time remains the same. Okay. Having said that, the projectile continues at the same speed horizontally. So that's what we mean, because the speed that it starts with is the same speed it goes along with throughout the horizontal distance, okay? And it accelerates vertically downwards. So this is just to tell us that there is no acceleration horizontally again. There is only vertical acceleration, which is the acceleration due to gravity, the g. Moving on. In the kinematics section, which we looked at before, we looked at a particle projected vertically only, okay? Here, we will look at an object which is projected horizontally, okay? You can take a flip back to your kinematics, which you were taught before, previous knowledge, on particles being projected vertically, okay? But here we want to look at particles that are, or objects that are projected horizontally, also projected at an angle, okay? Because we can, when we project an object horizontally, we always like to project it at an angle, all right? So a typical projectile follows a curved path, because when you project an object, you must actually have a path, like a trajectory, that the object would move. For example, projected horizontally, the path looks like this. So let's say this is where the object is being projected from. It goes like this horizontally. Now, the reason why you see that path of that object didn't just go straight horizontally like this. Let me show you that. It didn't just go straight horizontally like this. It did not. Now, the reason why that is so is simply because there is a force acting on that object while in motion. That is gravitational force. So there is what you call the acceleration due to gravity, pulling that object back downwards. So it can't just go straight, okay? Although it was projected horizontally, okay, but then that will actually make it come down a little bit based on that gravitational force. Okay, and that is why it gives itself an acceleration, which is acceleration due to gravity, to pull the object downwards. Now, moving on. When you have an object which is projected at an angle, the path that it takes looks like this. It goes this way, and then it drops back again. Okay, it's projected at an angle. That means you're not projecting it directly horizontally. You are projecting it horizontally, but at an angle. So you sit in such a way that the path moves this way. If the projectile hits the ground, this is the other part where the object is hitting the ground. If the projectile hits the ground at the same height, okay, with the initial projected position, then the path is said to be symmetrical. For instance, this is where it was projected from, and this is where it landed. You can see that they are on the same level. So that means the object landed on the same height with where it was projected from. Okay. This means that it hits the ground at the same angle that it was projected at. You can see that it looks exactly the same way from the beginning and from the end. So symmetrical, remember guys, it means that definitely if you draw a line of symmetry right here, let's take a look at that. If you try to draw a line of symmetry right here, it means that you'll be able to say that this is definitely half of the entire thing. So this side and this side are equal. So you can actually talk about the distance covered horizontally by the projectile. That is twice of from here to the maximum height that it reached. We'll explain more about that very soon. All right, guys, let's move on. A projectile moves in two directions simultaneously. Okay? Simultaneously. First, it moves vertically. So there will be a vertical velocity, okay, which is Vy. You can see it here pointed vertically upwards. It also moves horizontally. So there is a horizontal velocity, which is Vx. Okay? All right. You can see that here in this direction. Also, we resolve the velocities into these two directions, vertically and horizontally. Look at the motion vertically. We have initial velocity. Vertically, guys, don't forget. Initial velocity means uy. That is the initial velocity in the vertical direction. That's why you have y with it right here to differentiate between vertical and horizontal direction. Of course, you know that vertical is your y-axis here and horizontal is your x-axis here. So uy is for horizontal motion. Velocity at time t later, okay? That's not the initial anymore. That's not the velocity that it started with. That's a later velocity which we use v to represent. So vy in the vertical direction is a later velocity in time. Acceleration due to gravity, 9.8 g meter per second squared. We also have displacement that talks about the distance that was covered vertically again. That is why it is called sy. All right, let's look at the motion horizontally. We're going to have the initial velocity to be ux now, and then the final velocity or the later velocity to be vx. Acceleration is 0. Remember that, guys? We discussed it earlier on. So horizontally, if acceleration is 0, I mentioned this, that the final velocity and the initial velocity is the same. That means the velocities along that horizontal is always the same. It doesn't change. So initial and final, or at any point in time horizontally, will always be equal to each other. Velocity horizontally, therefore, is constant. Please take note of that. Now, the displacement is Sx. That means the distance covered along the horizontal direction, Sx. Take note of that, guys. Now, let's take a look at this example here. A ball is thrown at 5 meters per second at a direction of 30 degrees above the horizontal. Let's take a look at that. You see, it was projected from the boy's hand at an angle of 30 degrees this way. The path will go like this and then land right here. The velocity, which is the initial velocity with which the ball was projected, is 5 meters per second, as given in the question. Okay, you've seen the path of the trajectory already. Now, resolving horizontally, don't forget we have to resolve horizontally. Ux is 5 cos theta. I'm sure you remember how we got this from your previous lessons. Okay, of course, you use your SOHCAHTOA to do that. 5 just represents your cos theta here, definitely, okay, is definitely adjacent. You try to form a right angle triangle here, so adjacent over hypotenuse. Your hypotenuse is the 5 that you have there, which is the magnitude, okay? So 5 cos 30, simply giving you 4.33 meters per second. So Ux is calculated. Let's resolve vertically. You remember we said that a projectile moves in 2 directions simultaneously, horizontally and vertically. So we must find the horizontal initial velocity and also the vertical initial velocity. So Ux and Uy will be 5 sine theta. You remember how we did that. to get 2.5 meters per second. All right, the ball travels initially at 4.33 meters per second horizontally and 2.5 meters per second vertically, which is upwards. After projection, remember, the vertical velocity will change as it has acceleration acting on it, which is the acceleration due to gravity. But then that of horizontal velocity will remain the same. That is very, very clear. So keep that in mind. Moving on. Let's look at a simple example first, just projecting horizontally. A stone is thrown horizontally from the top of a cliff with speed 8 meters per second. The stone lands in the sea 3 seconds later. Okay, you can see the diagram right here. This is the path of the projectile. This is the height from which it was thrown, and then it landed right here. So your h in meters here, okay, is the height from which it was thrown, and then your d right here is the horizontal distance covered. Of course, there is also a vertical distance covered when it was actually dropping down. Question A, how far from the foot of the cliff does the stone land? So that is the horizontal distance they're asking there. And then number B, how high is the cliff? That is the height of the cliff here, the vertical distance covered. All right, moving on. To find the horizontal distance, just look at the horizontal velocity. Okay, we have to find Sx. Sx is your displacement horizontally, which is the distance in meters d in that diagram right here. So our Sx is our d in the diagram. Initial velocity, according to the question, is 8 meters per second. That is definitely your ux, which is equals to 8. Now, why did we say ux equals to 8? You know, we're actually supposed to actually find, what is it called? Okay, the vertical and horizontal components of the velocity. Okay, but you will see that this velocity this time around was not projected at an angle such that we will need to resolve that velocity vertically and horizontally. This one was actually projected horizontally. Okay, it was thrown horizontally. So the velocity is actually along, all right, the horizontal direction. So ux, the initial velocity along the horizontal direction, is directly that 8 meters per second. Well, if you are going to guess, you should know that the velocity along the vertical direction, or the vertical velocity, definitely is going to be 0 in this case. Okay, now final velocity Vx, we need to find it. Acceleration is 0 horizontally, remember that. So A equals to 0 because it's an horizontal motion for the projectile. The time is 3 seconds according to the question, so t equals to 3. So we have our parameters and their values and what we are looking for. All right. Now, let us use one of our formulas for motion. S equals ut plus half at squared. That is formula for distance or displacement. Okay. S equals ut plus half at squared. When you substitute your values, you're going to have Sx equals ux, t times t, then plus 0. Of course, since the acceleration is 0, everything here becomes 0. So you have your d, which is the same thing as the Sx, to be equal to 8 times 3. So you have that distance to be 24 meters. So the stone lands 24 meters away from the foot of the cliff. To find the vertical distance, just look at the vertical velocity. So let's do that. Sy, I'm going for question B now, okay, because we want to find the vertical distance, which is the height here. So we go with the vertical distance. Sy is your h, according to the diagram. Initial velocity is 0 vertically. I mentioned that already. So uy is 0. The final velocity is vy. We need to find it. And then acceleration due to gravity now, because we are already considering the vertical distance, there has to be an acceleration due to gravity g equals to 9.8 meters per second. Okay, all right. Time is 3 seconds. Okay, you can also call it a actually, but then we just put the value that we are using. So these are the parameters and the values that we have. Okay, so S equals ut plus half at squared. You will discover that the final velocity, we read it out, but then it wasn't given. And then we really do not need it to find the distance we are looking for. This is just to highlight all the parameters that is necessary in projectiles and see which one you can combine to give you the answer you're looking for. So we have S, U, A, and T. And one of the motion formula that we have that combines all of those parameters is your S equals ut plus half at squared. So using that and substitute your values, U is 0, T is 3, acceleration is 9.8, and your time is 3. So 3 squared there. Solving all that together, you're going to get 44.1. So that means that the cliff is 44.1 meters high. Moving on. Here is a little example to check your understanding. A tennis ball is fired out of a machine at 20 meters per second, horizontally. Horizontally. Question. At the same moment, okay, an identical tennis ball is dropped vertically. So the ball that this guy is holding right here is going to be projected horizontally this way, while the ball here is going to be dropped vertically like this. So I guess the question here is, which ball hits the ground first? Which ball hits the ground first? So if you take a look at that and we decide to say this guy should go like this, while this guy should drop downwards like this. Of course, you know that if this is going this way, it's going to not go in this direction because of acceleration due to gravity. You're going to expect that, okay, that line, I'm just going to, put it there in the quickest way I can. Supposed to go like this and then drops, something of that nature, and then this one is going like this too, downwards, and then it drops and probably hits, let's say this is the ground. Let's say this is the ground. So this drops and then this drops. So the question is, which one is going to hit the ground first? Is it the first ball this way or the one that just dropped this way? So let's find out. Anyone give us the answer? So I would like you to have your answers ready. Okay. Let's see what we have. You may think that the one that's fired hits the ground after the one that's dropped. But that is not the case, guys. They hit the ground at the same time. You've been wondering, wow, does that make any sense? Okay, why is this? Here are the two tennis balls moving. Pa. Okay, can you see that now? This drops and this is fired. You can see the way they moved. The tennis balls fall at the same rate because the only force acting on them is weight. Okay, and that is the same. They both have the same weight. So they will fall at the same rate. So that is why both of them will hit the ground at the same time. The only acceleration is your acceleration due to gravity, okay, which is the same acceleration that is acting on both of the tennis balls. So the horizontal velocity does not affect the rate at which they fall. So whether it was projected horizontally or it was dropped, it will move at the same rate because horizontally, there is no acceleration affecting it horizontally. So take note of that, guys. Okay, if you fire a number of balls at different speeds, however fast they are fired, guys, they all hit the ground at the same time. Let's play it and see. The ball is right here. We're going to fire a number of balls from there. Pow. Can you see? Let's see it again. Pow. Let's see it again. Pow. They will all hit the ground at the same time, no matter the speed that they were being projected at the same point. So guys, let's understand that. Moving on.